Hello, good day to everyone. I am Agi, your teacher in General Mathematics. This is our first class online, and so may I request you to click and subscribe the button and click the notification bell so that when there is a new video, you will always be notified. After watching this video, please click the link below for your attendance. May I also invite you to share this video to your friends and classmates so that they can understand and follow our lesson. So let's start. Once again, I'm Agi Padiaos, your teacher in General Mathematics. So the very first topic in General Mathematics is the introduction to functions. For us to have an in-depth understanding of this lesson, we need to define a term relation. Now, what is meant by relation? So when we say relation, it is a set of ordered pairs. Now, what do we mean by pairs? Of course, these are pairs of number. Whose ordered pair? Of course, it is the pairing of numbers represented by the x and y. Another term is function. Now, what is meant by function? It is a type of relation where there is exactly one output for every input. For every x, there is exactly one y. This is now the explanation of the set of ordered pairs we are talking in the term relation. It is a pair of an input and output. So meaning to say, when we are going to look for something, there is always an input. When we are going to compute, there is always the result. When we have the summation of a number, of course, there are always the addends. When we have the difference of a number, of course, our input is the minuend and the subtrahend. When we have a product, our input are the multiplicants. And when we have the quotient, our input are the divisor and the dividend. So that is the pairing we are talking when we are talking of relation. Let's move on. Now you will notice we have in here what we call the function machine. Now what is the very purpose of this function machine? Now this function machine further illustrate the definition of our topic function. You will notice in the function machine, for it to work, we have to introduce an input into the process. The process is called to be the function machine. Now, when the process works, it will give you a result which is called to be the output. Now, what is that input in math? That input is called to be the domain of the function, and the output is called to be the range of the function. Now, you will notice we have in here at least three concluding statement. For every input must have an output, meaning if you had something done in the process, there is always the consequence or the result. Two different inputs can have the same output, meaning to say, let's say in addition, when you add two numbers, it will give you one result. In multiplication, when you multiply two numbers, it will give you one result. That is the meaning. Another one in here is one input can have only one output, meaning to say there is a one-to-one correspondence of an input and the output, unlike in the statement number 2. Let's move on. It says in here, which of the following relations are considered to be a function? Now you will notice we have in here three sets of ordered pairs. We have the set of x. The question is the set of x represent a function or it is just a mere relation? Now to answer this, we have to consider the domain or the input. Now what are the domain of this set of x? We have in here 9, we have negative 5, 2, and 3. You will notice that the domain in here are not repeated. Meaning to say, the set of x can be considered to be a function. It is not just a mere relation, but it is a function. Now what about the set of y? Is it a representation of functions? Now let's try to analyze the domain. Now you notice that 6 is paired with A and paired with B. Meaning to say, the domain 6 is repeatedly paired with two numbers. Now the technique in here is when the x is repeated, automatically it is considered to be just a relation and not a function. What about the set of z? You will notice that the set of z is not also a function. Why? Because small z in here, which is the domain, is paired with 7 and paired with 0. Meaning to say, it contradicts the three statement we have a while back regarding the function. You will notice in the three sets of ordered pairs that no two ordered pairs can have the same first coordinate. Identify the domain and range, then tell if the relation is a function. Okay. You will notice in here we have a set of ordered pairs, the input and the output. And you notice that negative 3 is paired with positive 3. 1 is paired with positive 1. 3 is paired with positive 1. 4 is paired with negative 2. Is it a function? You notice in here that the input negative 3, 1, 3, 4 are not repeated. And so the answer is yes, it is a function. Each input is mapped onto exactly one output. How about this one? You notice the input is composed of three domains and the output is composed of four domain range. You notice that negative 3 is paired with positive 3, but 1 is paired with negative 2 and 1, and 4 is paired with positive 4. You notice in the input that 1 is repeatedly paired with the values of the output, that is the negative 2 and positive 1. Therefore, this one is not considered to be a function. How about this? You will notice we have in here the set of x and y. Now, in the first set of x and y, 1 is paired with 6 and 1 is paired with 7, whereas 2 is paired with 7. You will notice in here that 1 is repeatedly paired with 6 and 7 under y, and so this is not a function. How about the next statement? or the next set of x and y, you will notice that your 1 is paired with 6 and 2 is paired with 6. You notice in here that your x 1 and 2 are not repeated, and so therefore the set of ordered pairs is considered to be a function. Here is the answer. Not a function and a function. How about this? You will notice in here that the function is illustrated by using a simple equation. Okay, so xy chart, and we have in here the mapping. Now you will notice in here, if we are going to study them thoroughly, now in the xy chart, you can immediately cipher if the equation is considered to be an equation for a function or not. Why? You can see immediately if the values of x or the input are repeated. As you can see in the y chart, the values of x are not repeated, and so therefore it is considered to be a function. You notice also in here that the xy chart can also be illustrated through the use of mapping, wherein the input in here stands for x and the output stands for y, wherein your -2 is paired with -4, -1 is paired with -2, 0 is paired with 0, 1 is paired with 2, 2 is paired with 4. Now, I repeat, that equation is considered to be a representation of function. Now, what about this one? Is this a function? Again, to answer this, you have to analyze if the domains or the values of x in the set of ordered pairs are repeated. If not, they are considered to be a function. So number one, set of ordered pairs are considered to be a representation of function. Now what about the number 2? The number 2 in here, immediately it is not a function. Why? The domain 1 is paired with 4 and the domain 1 is paired with 5, and therefore number 2 is not a function. Next, number 3. You will notice in here that the x or the domain or the input in here are not repeated, and so therefore number 3 is a representation of a function. Another thing is the vertical line test. Now, what is meant by vertical line test, or what is the purpose of the vertical line test? Now in here, this is the visual tool to identify whether the graph is considered to be a graph of a function or not. So it says in here, if it is possible for a vertical line to intersect a graph at more than one point, then the graph is not a graph of a function. Now consider viewing this illustration. So you will notice So you will notice 4.5 is 4.5, meaning to say they are aligned to each other, meaning the values of x is repeated. So that if these are repeated, automatically in the graph, they are also aligned. And so that if that is the case, the graph is not a representation of a function. How about this? You will notice that there is no point vertically aligned to each other. And so this graph is considered to be a graph of a function. Determine whether or not these graphs are functions. We have in here a diagonal line. It is the graph of a linear equation. The question is it a graph of a function? Let's use the vertical line test. You notice that the vertical line only intersects the diagonal line at exactly one point. So we have in here exactly one point. And so if that is the case, this graph is considered to be a graph of a function. Another one in here is the graph of a parabola. Now to check whether this is a graph of a function or not, use again the vertical line test. So you will notice our vertical line test in here intersect the graph at exactly one point we have in here. And so if that is the case, then this graph must be a graph of a function. How about this? We have in here. Is it a graph of a function? Yes. Why? Let's try to see the vertical line test. The vertical line test only intersect the graph at exactly one point. And so meaning to say, this graph is considered to be a graph of the function. How about this one? You will notice that it is the graph of an oblong. Now you have in here two intersections between the vertical line test and the circle. So we have this part and we have this part. And so this is not a graph of the function. So this is the end of our first lesson in the general mathematics. So before we end this lecture, please subscribe and click the notification bell so that you will be reminded of the new lesson posted. Again, if you have queries, just type in the comment in your Facebook page. And do not forget to have your attendance below the description. Just click the link and fill in the necessary information that you have watched and studied this lesson. Thank you for listening.